This experiment is about on how to use a transistor as a switch. You are given a circuit which will use the LDR, which is this, and then you want to switch on a relay. First, before you do this, what you should do is you need to measure what is the resistance of the LDR when there is a light and when there is dark. And then you also need to measure what is the resistance, DC resistance of the relay. If you measure the DC resistance of this relay, you will see that the DC resistance is 70 ohms, and then you need to measure what is the resistance of this when there is light and when there is no light. When there is light, the resistance is 6.8 kilo ohms, and when there is no light, the resistance is around 90 kilo ohms. So the resistance of this LDR goes from 6 kilo ohm to 90 kilo ohms. This thing, if you measure what is the current through this is a 5 volt, 70 ohms. This will give you around 0.07 amps or 70 milliamps. Okay, now this is the typical circuit. Transistor as a switch. So this is there is a series resistance in here, 70 ohms, and you need the current of 70 milliamps. Now, no matter which one is the which one that you want it to be, depending, this is switch on when there is light or switch on when there is no light. But what you need is 70 milliamps to switch on the relay. You need to find what is the R, so that to set this thing, and you know this is the variable resistance, which is the LDR, that run from 6 kilo ohm to 90 kilo ohms. So you need to find this value, so that when this is 6 kilo ohms, this will give you 70 milliamps in your IC. Then the supply, say this is 5 volt and this is 5 volt. Then you need to find what is the suitable resistance that will change the resistance, change the VB from less than 0.7 to greater than 0.7. So when the resistance is high, this thing will be more than 0.7. When the resistance is low, this VB must be less than 0.7. So you, at the same time, this value of R has to satisfy, so that the equivalence of this, so this is the V Thevenin, which is the combination of this R and your LDR. This is your VB. So this flow into your E, and you need to find what is the suitable V Thevenin, so that your current is 70 milliamps. Let's say the beta of this is 300 for typical small signal transistor, something like 2N222A as you use in your lab for this experiment. So you can estimate what is your IB gonna be. So 70 milliamp divided by 300, so this will be your IB. This IB is 5 volt divided by R Thevenin, which is your RP, and you will have your R Thevenin. You know that you want it to be 0.7 and more than 0.7. Then you can calculate, or you can find what is the value of R that is suitable to switch on the relay when there is light and when there is no light. So this is your pre-lab is all about. You should get ready with all the calculation and change the respected value with the actual value that you measure in your lab.